Hey there, good morning, or afternoon, or evening, whenever you're getting to this. 14.4, Matrices and Systems of Equations. Make sure you have your graphing calculator handy. We're going to use the matrix menu on that here in a little bit. So what we're going to cover here is a system of equations as what we call an augmented matrix, row echelon form, and what we call reduced row echelon form. And using this tool, which we'll be using our calculators, to solve systems of equations and larger ones, big ones. Okay. So we know from other matrix work that a matrix is rows times columns. So it has m rows, n by n matrix. It always goes rows first, column second. Okay, rows first, column second. These little addresses tell the specific location. So 1, 1 means first row, first column. 3, 2 means the third row, second column. Okay? So the order of a matrix is just basically how many rows, how many columns. So a few terminology things here. If they say determine the order of the matrix, we'd say it is a 1 by 1. This one would have 1 row and 4 columns, so it's a 1 by 4. The order is 1 by 4. This is a 2 by 2. Okay? A few other things. A square matrix is when m and n are the same. So the same number of rows, same number of columns. So this down here would be an example of a square matrix. These are the main diagonals. If you start at the top left and go here, this is your main, what they refer to as the main diagonal. Okay, but that's only with a square matrix. If a matrix has only one row, it's called a row matrix, such as this. Okay, if it only has one column, it's called a column matrix. So that'd be something with just one column. 1, 2, 3. Column matrix. Woohoo. Okay, so writing a system of equations. If we have a system of equations like this, you can write it as an augmented matrix like this. So notice these are the coefficients from the system. This row are the solution. This is what it equals. So our coefficients go 1, negative 4, 3, 5, and then the 5 for the solution. 1, negative 4, 3. These are just some sort of separator. We're not even going to use those in our calculator. We're just going to make the whole matrix like this. 1, negative 4, 3, and then 5. Negative 1, 3, negative 1, negative 3, negative 1, 3, negative 1, negative 3. So you recognize like that. If you drop the bottom part off, they call it just a coefficient matrix. These are the coefficients. Okay? Note the use of a 0 for missing coefficients. Okay, there was not a y in this one, so you put a 0 in that place in both of those. So write an augmented matrix. So if we have a system of equations right here, and they want us to write an augmented matrix, it would be a 4 by 1, 2, 3, 4. It'd be a 4 by 4 matrix. But if we look closer, notice I have an x, y, w. Here I have a y, z, w. I have another variable here. So we're going to have to add some zeros here, and I shouldn't have 4 columns. I should actually have 5 columns. Okay? So I'm just going to write the coefficients. I'm going to start along the top. So it's 1, x, y. So sometimes I write this up here, x, y, z, w. X, y, 3, z, no z, so I'm going to put a 0 there. W, negative 1. Draw my dash mark. On the right side, I'm going to put a 9. Next row, negative 1, 4. Ooh, hang on. 0, there's no x. Negative 1. Z is 4. W is 2, and then that equals negative 2. X is 1. Y is 0. Z is negative 5. W is negative 6, and then that equals 0. X is 2. Y is 4, Z is negative 3, and W is 0, and that equals 4. So that would be your augmented matrix. It would be a 4 by 5 for its order. Okay? And we're going to come back to this, and we're actually going to solve this here in a little bit. Row echelon form is something I'll just introduce, so when you see it, you've at least seen it. I can say I've seen it. A matrix is in row echelon form when any rows consisting entirely of zeros occur at the bottom of the matrix. So you can't have a row of zeros right here and be in row echelon form. For each row that does not consist entirely of zeros, the first non-zero entry is 1, called a leading one. So when I look at these examples down here, anything that has the reds, this would be in row echelon form. Okay? Because any row that does not consist entirely of zeros, the first non-zero number is 1. So you can't have another number there that's not in 1. This one is no, because the row of zeros did not occur at the bottom. Okay? This one's yes. No rows of zeros, and every other row starts with 1. This one is yes. The row of zeros is at the bottom. This one's a no, because you have a non-leading 1 in there. Okay, so that's what they call row echelon form. How this is used is in a matrix. You can convert this into row echelon form, something called row operations. And it's very similar to what we would do to a system of equations when we multiply by something then add it to another equation. And you can do that with row operations. We're not getting into this on the video. I just want you to know row echelon form and what it looks like here. What we will be using is something called reduced row echelon form. Okay? So this is more helpful than row echelon form because only non-zero numbers are the ones down the main diagonal. All other numbers are zeros. Okay? So this right here, oops, none of these would be in reduced row echelon form because everything else has to be a 0. Okay? So reduced row echelon form has to have ones down the main diagonal. So like 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And what happens is the calculator does a bunch of these operations and it makes this 1, 0, 0, 0, 1, 0, 0, 0, 1. It makes it an augmented matrix, let's say 4, -2, and 3. And this is something we're going to get back from our system of equations on our calculator. So remember, the first row was our x, the second row was our y, our third row was our z. So in this case, what this means is 1x plus 0y plus 0y, 0z equals 4. So that means x equals 4. Y equals -2 and z equals 3. You have solved the system of equations using that reduced row echelon form. Okay? So let's go back and practice with this one. Let's see what we get for a solution. I haven't worked this one out, but what we do, here comes the calculator. We have to put this into our calculator. It's a 4x5 matrix, so matrix button is right there. I'm going to go second matrix. You may have some dimensions in there already. That's okay. Just go edit. I'm going to edit matrix A, and I want it to be a 4x5 matrix. I'm pressing enter between those numbers. Okay, now I need to enter these numbers. So 1, enter, 3, enter, 0, enter, -1, enter, and just put the 9 and enter. You don't worry about the colons or anything like that. Just do a 4x5. 0, enter, -1, enter, 4, enter, 2, enter, -2, enter, 1, 0, -5, -6, 0, 2, 4, -3, 0, 4. Okay, so get all those numbers in. We're going to go back to our home screen, so quit, second mode, quit. Now we want to go back to the matrix menu, go to the math column, okay? And if you scroll down, a lot of these we won't be using. There's that augment. If you want to put two matrices together, you can do it, or just type it in like what we did. Convert matrices to lists or lists to matrices, you can do that. A cumulative sum, that's what CumSum stands for, cumulative sum, adding things up. Okay, so A and B here. REF stands for reduced row echelon form. So I'm going to do that one first. You can hang on. We do want to use the RREF. So what reduced row echelon form, I'm going to select enter and then second matrix, choose matrix A. I get decimals. If you want fractions, you just go convert it to a fraction. And then you can scroll right and left to get any other number that you need. So what happens here is row echelon form doesn't give you the rest of the zeros. And you have to do more work when you're solving this. So down here at the bottom, the 1, remember the fourth column is a z. So it says z equals negative 137 over 87. That's a nice clean number. So if you go up a row, here you have 1y plus 20/23 z equals this. So now you have to take your z value, plug it into the next equation, and solve for y. And then once you have your z and your y, you move your way up, plug them into the third equation from the bottom, plug in the z value and the y value, and solve it that way, and work your way up. So row echelon form creates a lot of work. Sometimes it is helpful. We want to do the RREF. So that should give us zeros in those other spots. So RREF, and we want to use matrix A. Let's see what it gives us for that. Okay, some weird decimals. Let's go back to fractions. Okay, so this is where this is nice. Now there's ways to do this by paper, but look at these answers. Ugly. Okay, we don't want to do that, and this has done it all for us. So what this means is where these four planes, these four surfaces intersect, what they have in common, x has to be negative 302 over 87. Y has to be 316 over 87. Z has to be 104 over 87. W has to be negative 137 over 87. Those are your four solutions. Those you can write as what they called an ordered quadruple. So we'd go x, y, z, w. So you go negative 302 over 87, 316 over 87, 104 over 87, and negative 137 over 87. Okay, and those would be your solutions. Those are your answers. Okay, all on the calculator. Okay, so let's do this one. Use the matrix capabilities, graphing calculator, to reduce the augmented matrix corresponding to the system of equations into reduced row echelon form to solve the system. So we need to put into our calculator our augmented matrix. We have x, y, z, w. So 2, 1, negative 1, 2, negative 6. So, and you can go pretty much, you wouldn't have to write this out, 0, 1, 1, and just get this in your calculator. 5, 2, negative 1, 3. Okay, so now I got to go put this in, 4 by 5 again. 2, nope. 2, 1, 2, negative 6. 2, negative 1, 3. Okay, if everything went in correctly, I'm going to go matrix, reduced row echelon form, and matrix A, see what we get. There we have it. Look at that. So what this means, x is 1, y is 0, z is 4, and w is negative 2. So that row echelon form tells us that we have 1, 0, 4, negative 2. Those are your answers. So if you plug 1 in for x, 0 for y, 4 for z, and negative 2 for w, you'll get negative 6 in this formula. You do it here, you'll get 1. Do it here, you get negative 3. Do it here, you get 3. So those are the solutions that work in every single one of those. Okay. Now, not everything does work out quite so nicely. Okay, so an infinite number of solutions. How we handle that? So we're going to plug this one in, x, y, z. So notice here we have 4 equations, and we only got 3 unknowns. So we have a 4 by 4 matrix. So I'm going to edit, make this into a 4 by 4 matrix. 3, 3, 12, 6. 1, 1, 4, 2. 2, 5, 20, 10. Negative 1, 2, 8, 4. Okay, so what happens here when you do that reduced row echelon? Let me reduced row echelon for matrix A. Not everything is going to cancel off. Okay, and we get these zeros here. And this is a clue that we're going to have some sort of infinite solution. So we have x equals 0, and then we have y plus 4z equals 2. So how this gets written is we know x equals 0, and we have y plus 4z equals 2 from that second row right there. Now we don't have anything for z, so we're going to say, okay, z can be any number, a for any number. So z is going to be any number. We're going to plug this back up into here, and I get y plus 4a equals 2. So let's solve for y. And we get y equals negative 4a plus 2. Okay. So this is where our answers come from, actually. Okay, we know x has to be 0. So x is going to be, remember, we have to have x, y, and z. So x has to be 0, y has to be negative 4a plus 2, and z can be any number. And that's how it's written. It's an ordered triple. That's what your solution is. Okay? Because there's an infinite number of solutions. So you can pick any number for a. Say, okay, I'm going to pick 5 for a. If I pick 5 for a, then I have to pick negative 18. If I plug 5 in here, I get negative 18 for y. So if I do 5, negative 18, and 0, I'm going to get 6. 5, negative 18, and 0, I'll get 2. Okay? So let's try another one with that here. This is going to be a 3 by 1, 2, 3, 4, 5. A 3 by 5 matrix. Let's edit that. 3, 5. So 1, 1, 1, 1, 0. 2, 3, 1, negative 2, 0. 3, 5, 1, 0, 0. Reduced row echelon form, matrix A. Okay, so let's try to figure this out. First row is x, y, z, w. Okay, so x plus 2z equals 0. So x plus 2z equals 0. That comes from the first row. Here I have y minus z equals 0. And then here I have w equals 0. So my formula that I don't know is z. I don't have a value for z, which means z can be any number. So z is going to be a for any number. So let's solve this. X equals negative 2a, and y equals a. So x is negative 2a, y is a, w is 0, and z is a. So our answer would be negative 2a, a, and 0. Okay, check. Negative 2a, a, yep, okay, same answer. Okay, and this is actually number 89, and you're going to do 90, and this one up here was actually, I think, 85. So those are some examples from around the ones that you've been assigned. Okay, but this is how your answer gets written. I'd like to see this work, if at all possible, or just take a picture of what your work is doing and send that to me, or take a picture and upload it into your Google Sheet. Do something. I'd like to see that work instead of just seeing these answers down here. So that's it for this lesson, working with the order of the matrices, dimensions, being able to use your calculator and figure this out. And then this is probably the trickiest part, is getting these answers when you have infinite solutions. So let me know what I can do to help, and we'll see you soon. We're getting closer and closer to the end.